Earthquakes, they cause confusion, destruction and mayhem. People lose their homes or even their lives. And these aren't just one-off events, they happen frequently, and so this is where engineers need to step in to help lessen the impacts by making stronger structures and designing better management strategies. What are they exactly? They're seismic events that cause vibration on the Earth's crust, produced by interaction between tectonic plates. The Chile Earthquake in 2010 had a magnitude of 8.8 on the Richter scale and resulted in 479 deaths, environmental destruction, as well as $30 billion worth of damage. Civil engineers work on improving the stability of structures to avoid these sorts of incidences in the future, to make sure that in the end, people and infrastructure are safe. The O'Higgins Tower experienced partial collapse on the 10th, 14th and 18th stories in the walls on the east and south faces especially. This happened because the forces from the earthquake act at the centre of mass and the resistive forces at the centre of rigidity. The distance between these two centres was big due to the asymmetrical architectural design. Therefore the building was forced to twist, and so the walls failed and collapsed, with the forces being concentrated at the front. The lack of continuous reinforcement and the irregular structure also contributed to this. The earthquake also caused the collapse of the Las Palmas tailing dam, causing the death of 4 people. Lead and mercury were released and absorbed by the soil. Also, high concentrations of cyanide have been found in the nearby water after the dam's failure. The dam failed because it used an upstream design made of granular soil, which had a low slope stability safety factor. As a result, the dam liquefied, which is where the shaking causes the soil to act as a fluid, releasing its content into the surrounding area. Problems can also be found at the Estadio Nacional in the event of evacuation. There is not enough space between rows of seats, therefore people get injured due to panic, so the fallen people might be stepped on by others. Also, there is an excess of people trying to leave through one exit, which is highly unsafe and may lead to further potential injuries. If the O'Higgins Tower were to be reconstructed, a pyramid shape would be the most stable, since its centre of gravity is low, making it hard to topple over. Trusses could be added throughout the building, providing greater stability, as well as horizontal beams with diagonal beams between them, in order to create a structure with more stiffness. In order to prevent tailing dams from failing, they have to use a higher safety factor, by using different materials or decreasing the slope, and have a different and more stable design, such as downstream or centerline. For the stadium, a barrier should be set up at exit D, as shown in the diagram, in order to direct part of the crowd to exit A, instead of exit D. This will make the evacuation more efficient, and at the same time less congested at the smaller exit D. Besides that, big illuminated signboards should be installed at eye level to make the direction for the evacuation clear and easy. Overall, it's not the earthquake that kills people, it's the failure of buildings that do. By making the O'Higgins Tower structurally stronger, changing the design of the Las Palmas Dam, and creating evacuation routes where people can efficiently exit buildings to safer areas, people's lives, economies, and the environment can be protected.